Assalamualaikum, my name is Nur Fazli bin Huma Idris, CE190107, and I'm going to explain about the assignment 2 from the slide. So for the introduction is a fuzzy logic controller is the best tool for controlling the speed of the DC motor. The fuzzy logic is based on the theory of fuzzy sets, where an object's membership of a set is gradual rather than just member or not. Fuzzy logic toolbox, which is one of the applications in MATLAB software, is used. So, for the fuzzy logic system, it is most important to define the range of input and output membership function in the fuzzy interference engine. Then, with the appropriate fuzzy rules, the accurate controlling system will be developed for the DC motor speed control. So, the next is the instruction for the assignment 2. We are required to design a fuzzy logic controller to control the speed of direct current motor, and then the given transfer function is 0.036 over 36.942 s squared plus 12.156 s plus 0.451. So we need to simulate the DC motor, and the speed is set to be 120 RPM. Next is the Mamdani type fuzzy. So this algorithm is implemented in MATLAB with a 5-member fuzzy inference system used for the input parameter. That is zero, that is error and change in error, and also for the output. Mamdani type fuzzy interference approach is utilized. The set is shown as the picture. Next is the membership function of the input to the fuzzy logic controller. So here we can see here, this is the range, in display range is equal to 0 and 120. And then for the NB stands for the negative bit with the numerical equivalent of 0. And we can see the graph is in the triangular shape. After that is the rule viewer for the fuzzy logic controller. You can see here the input is 62.2 with 59.45, and the plot point is 101. The error and the change in error and the value of the speed controller is different. You can see the difference in the diagram. Next is the dimensional view of the fuzzy logic controller response. So this is when we run the simulation, and the 3-dimensional behavior of the controller is shown here. So you can see here the X match point and Y match point is set as 15, and this is the image. So that's all from me. I will pass to the next presenter. Thank you.
Assalamualaikum, my name is Nur Nabiha binti Muhammadiyah and my matric number CE190179. So I will demonstrate the assignment 2 using the fuzzy logic controller. This is the block diagram for that we designed for the fuzzy logic controller. First, we use step, sum, 3 scope and derivative, and the bus creator. And then we have fuzzy logic controller, which rule viewer, and the gain, which is 155, and the transfer function from the instruction. And the last is the scope for shows the graph waveform. For using fuzzy logic controller, we need to set the fuzzy in the command, and then the fuzzy logic designer will display, and then we import the fizz file that we save to the folder in the PC. This is fuzzy speed control that I already create. We have 2 input, which is error and change in error, and then the output is speed controller. So from this input, we already set the error, which is NB, NM, ZR, PM and PB, which is we have 5 names here. Also in change in error, and the speed controller. From here, we can see the surface graph. You can see, and then we also know the graph, the error. And this is the rules that will display for error, transition error, and speed controller. First of all, we need to import and then export to the workspace. If we already export to the workspace, we can see the export file. We can type the export file to the fee structure, and then just run. And now the fuzzy rules will display, and we can see the scope. Double click the scope, and the graph shows. That's all for me. Thank you.
Assalamualaikum. My name is Nurshaliza binti Abdul Halim. Okay, now I will present about fuzzy logic control system. As you can see, this is a block diagram for fuzzy logic control system. We have a step, and then sum, derivative, fuzzy logic controller with rule viewer. Okay, so the gain for this block diagram is 100. Okay, so this is the function, transfer function. Okay, the equation is 0.036 over 36.942 s squared plus 12.156 x plus 0.451. Okay, so this is a scope, which is the graph will be appear at the scope. Okay, so the fuzzy logic controller is applied to the DC motor. The setup in MATLAB simulate environment. Next, a unit state signal is applied to a fuzzy logic motor control system. Okay, so next is response of fuzzy logic control system. Okay, so as you can see, this is the waveform after we run the simulink. So this is the waveform that we get. Next, the output depicting the response of the DC motor is displayed via a scope after simulation. The integral gain is set at 20 as 0, steady state error is N. The setting time is 0.5 seconds. Next is the fuzzy logic Mamdani type base control has a sluggish response to the input signal. It has no overshoot though. The settling time is 1.8 seconds. It requires no tuning, and human manipulation are eliminated or otherwise reduced. Okay, next is conclusion. So the conclusion for this experiment is controlling a DC motor using fuzzy logic, which is Mamdani type controller, show an applicable performance, though not optimal. Fuzzy logic based controller require no tuning but has a sluggish response to the input signal and cannot readily predict stability as well as robustness of the DC motor. So there are still more rooms for improvement in this regard. So that's all for my group presentation. Thank you.